Yeah, I think would be good to have somebody. You can do it remotely as well. Thank you. Just have to, mostly focus on the decisions and outcomes of discussions. You don't have to get every word that is spoken. So, all right. This is the Privacy Pass session at IETF 119. Hopefully you're all in the right spot. Let's see if we can get, all right. You should be familiar with the note well by now, but this is, kind of outlines the rules of the IETF with respect to intellectual property and also with respect to how we treat one another. So please be familiar. There's also the note really well, which goes into various expectations of conduct. For meeting tips, please, if you're in the room, please sign in using the online tool or on-site tool so that we get an accurate count of people in the meeting and so that you can join the queue. If you're a remote participant, please, mute and turn off your video except when you're chairing or participating in the discussion. Let me just also introduce myself. I'm Joe Salloway, and I'll give Ben a chance to introduce himself since he's participating remotely.
Hi, I'm Ben Schwartz. I'm also a co-chair of PrivacyPass, but I'm participating remotely from New York City.
Ben, your audio is a little bit low. All right, here's a list of some of the other resources. And now we get to the good part here, which is our agenda for today. We'll have some brief update of some of our core documents. Then a discussion of some of the newly accepted work or adopted work in metadata. We'll look at some new work that Watson Ladd has proposed, and then we'll have some discussion led by Stephen Valdez and Martin Thompson on kind of PrivacyPass and how it's interacting with the web as a whole. So that should be interesting. Does anybody have any other items for the agenda or any agenda bashing that needs to be done? All right. Then I'll go through just a brief summary of where we're at. The core documents, I believe, are all in the RFC editor now. We have a document in working group last call, which is batch tokens. Unfortunately, I think the document has expired. I'll get the authors to submit a new one, but you can still put in your reviews. I believe the last call goes past the IETF week. We can extend it if necessary, but please take a look at that document. So next is Stephen, do you want to give an update for key consistency? Let me see. Can you do that again? I think I double clicked when. There, you should have it now.
Hi, I'm Stephen Valdez. I'll be giving an update on the resource consistency draft that we adopted I guess, a couple of months ago. The general layout of this is we'll go over the big open issues that have questions that it would be good to get the working group to give some input on. There's particularly some things around client fetching patterns and how you consider authenticity versus what we're giving through this API, which is the consistency. Then just the other issues that are mostly editorial, and then next steps for this draft or related work. So the first big issue that we need some sort of resolution on is that this draft uses binary HTTP to encode and encapsulate the resource that we're trying to be consistent about, which currently just encapsulates the whole thing, all headers. It was brought up that you only really need to encapsulate the contents and maybe some other headers. Content type is the one that was brought up. It's an open question if there are other headers we think are valuable to encapsulate right now, or we should just drop to doing that one header and content. I don't know if folks here have strong opinions in either way.
Yeah, so Martin Thompson, I think I made this comment. I will observe that if you only care about the content, you can just hash it and have a digest field coming back from the consistency check, which is pretty nice, aside from the potential for header fields to change the way in which that content might be interpreted. So I don't think you need to worry about content codings or anything like that, but you may want to make sure that it's the right JSON variant, for instance, in case there's been some changes in the way that the different JSON payloads get interpreted, for example. So I would be comfortable, I think, with just a head request on this one, if there's a recommendation that use digest fields and content type, which is not what is in the draft at all.
Yeah.
But I think it achieves the goal that we're looking for, which is that you can confirm that the content is the content that you expected.
Yeah, I think this gets in a little bit into the later slides about authenticity. But yeah, I think that definitely would be a simplification for like certain ways of shaping this. But maybe we should open that up as a separate issue from the binary HTTP question. Seeing no other comments on this issue. The next big issue we have is configuration rotation. This is a problem of if the mirror has cached like the resource, but the client has either gotten a more recent resource or got it in a slightly different way, there's going to be an inconsistency that shows up. And like, this isn't actually a malicious attacker. And figuring out how we resolve this inconsistency, whether like the client has to be retrying and refreshing, if we have some, just leave it up to the application and leave some security analysis or do something else. I think on the thread, it's been mostly leave it up to the application layer and not have strong opinions in the consistency draft itself. But if people have thoughts other than that, I think that really there is a lot of like intricacies depending on the application. So solving it here, other than giving like best practices, may be out of scope. Not seeing any. Oh, Ben.
So I don't quite understand how you get into this situation. Are you saying that the origin copy of the resource changes before its expiration time? Is that the situation you're talking about?
Well,
So like the origin server puts something out, it has a freshness lifetime of an hour, but half an hour later it actually changes the content, so now the cached copies don't necessarily agree.
Yeah, if the mirror saw a longer lifetime than like actually happened, or that the client saw, or like if the client's always just getting the latest one, which is separate from the lifetime. So if lifetime, it doesn't actually mean how long it's getting served, which you can imagine with like some origins serving overlapping lifetimes.
Yeah, I mean, my view is that is like not a supportable configuration. We can't, like, if we can't really allow that, because there's no way to check the consistency anymore. There is no consistency, like, because some users may be accessing the resource through an intermediate cache. So you failed consistency at that point.
Yeah. So Ben, I think we can't avoid this either. And that's, I think, the key question that we have in front of us is that at some point we need to allow for the possibility that a config might change at a resource might change, right? When these are not permanently immutable. But at the point that it changes, there's going to be a bunch of caches out there that exist for the purposes of doing consistency checks that will have out-of-date content. And any client checking with those at that point will find that they don't have the right content. And that's just hard. It's possible, perhaps, to solve this with having multiple resources and having consistent mirrors of each. And so you suggest you have clients switch between one of two, for instance, and then consistency is achieved with either of those two resources. That might be one way of dealing with this sort of problem. This is a problem we have in a lot of other contexts as well, in terms of just how do you upgrade a protocol to support a new algorithm or something along those lines. I think we need to have some sort of mechanism for solving this problem.
Yeah, though I guess with that approach, even if you have multiple, there will always be a case that you have the worst case timing, and every entity here is going to be like inconsistent with each other. And even like if you don't allow overlapping, and like lifetime is exactly how long a server's like handing a thing over, like time is a falsehood, and like different resources or different entities on the network may believe the lifetime expires at different times, which like is completely okay behavior mostly, but will introduce these sorts of problems. And I don't know if we want to say you have to have perfect caching, which seems hard.
So on Martin's point, I do think that there is a, like, in theory, there is a discipline that makes this go away. And that is to say, if you put up if you serve the resource with a cache lifetime or a freshness lifetime of 1 hour, then you've committed to that resource for 1 hour. You can't change it. If you want to change it, you have to wait until all extant copies have expired. And then you have an opportunity as the origin to change it. And yes, this then leads into this other ladder thing that we talked about separately.
But I guess it sounds like this is a common enough problem. I think like has enough sharp edges. Maybe it is worth having at least more language in this draft, even if we can't solve it for like all application use cases. Because I think this is just like there's even more sharp edges that may not be obvious to applications built on this.
Tybalt?
Yes. So I think I agree with Stephen. It's mostly like a wording in the draft, because you might have the origin send a resource for like with a cache lifetime for 1 hour, and then the consistency proxy cache it again for 1 hour per the draft. And I think the issue is like with this intermediary cache lifetime, which like kind of virtually extend the lifetime that the origin sent initially. That's like, I think, a wording issue in the draft.
Well, seeing no one else, the next issue we have is somewhat similar in terms of the expiration. There's a problem of if we have these sorts of lifetime things and like a lot of clients hit their lifetime and now their resource has expired and they're like getting new ones. This is a lot of traffic going to the consistency mirror. Maybe some solutions are a thing where we only do head requests because we only care about the digest. Other things are having some logic for clients checking at different times that are not related to their lifetime, or this latter strategy of where you serve multiple versions of the resource with overlapping lifetimes. I think parts of this probably go more towards application layer, but some of it at least like needs to be specified so that consistency mirrors know what sort of traffic patterns they're going to experience. And yeah, maybe there needs to be a more explicit, like what does expiration really mean for resource consistency in the draft compared to what wording we currently have. Any comments on this one? Martin?
Too long to switch tabs. This is related to the previous discussion about having a fixed lifetime. If you have the resource commit for the hour, if you try to ensure that there's a clean breakpoint at which the resource is no longer valid, then you have guaranteed a thundering herd at that point in time. And I don't want to have that happen. So let's not use that solution there. Otherwise, yeah, most times I think the natural access patterns of clients will ensure that you don't get a thundering herd, but you will have to ensure that you don't create any synchronization mechanisms. And that previous solution that was perhaps suggested by Ben, I think, does create that situation.
Moving on to the next issue. So there was a comment brought up that because clients are directly accessing the mirror, there's a client IP leakage. Some solutions might be requiring multiple mirrors in your application, so no single mirror will see all the clients, or it'll be spread out across a larger set of pools. This probably is just some privacy language in the doc, and we don't actually need to solve this. I'm curious if people have other thoughts of requiring HTTP or requiring larger pools of mirrors. If not, the next issue came up during the adoption call. This is mainly about how the current draft mostly focuses on the mirror being the place you fetch the resource from, and you could probably just trust that and it'll be fine. But this isn't actually true because the mirror is only giving consistency and not authenticity. It doesn't prove that the resource came from where it actually said it did. I think different applications will see this in different ways. There's applications like main PRIVACYPASS where the keys are coming in as part of the challenge. So you already have the real resource. You're just using the consistency to compare against that. The other applications may want to explicitly call out that they have to do a fetch to the origin. The question is what we write in the draft. If we specifically call out that this is as a problem, require that you do this origin fetch, which I think makes complicates the PRIVACYPASS story, or if we just leave it in security considerations and let this whole content binding be a thing solved in the application layer. I think we'd probably lend towards the mention it as a thing in security and not enforce anything, just given that our main use case for this wouldn't want to do a separate origin fetch. It would want to use the keys that it already got through the protocol. I guess Martin's probably if you have any comments here, since I think you're the one who brought this up. Otherwise, that's a reasonable approach.
Yeah, so the reason that I brought this up was that the draft talks about the second request that you make, but basically said nothing about the first one that you probably need as well. And so just put some text in, I think, was really all that was requested.
Sounds good. Then there's a few other issues on the repo. A lot of them, I think, are wording or clarifications. Some of them do overlap with this consistency lifetime thing. So hopefully resolve those as resolving the previous issues. If any of those turn into larger discussions, we'll bring it back up to the list. So next steps, I think, are resolve the issues or dig further into the issues mentioned in today's discussion. There's a couple of other comments, including Martin's proposal about doing digest instead, that maybe we should open up some issues about and have discussion about on the list or on the GitHub. The other question is about implementations and if there are any plans for folks to make up implementations. I don't know if there are any immediately, though I think there's been various mumblings of folks interested in doing something in this space. I think that's it for this draft.
Okay, any other questions or comments? Ben?
Hey, I just want to emphasize that this topic of whether it's permissible for the origin to have essentially multiple outstanding inconsistent copies of its resource that are all fresh simultaneously is, I think, very fundamental to this draft. I'm not saying that it must be one way or the other way, but the whole logic of this protocol is built on some assumption at that level. So I think we need to be very careful about what we say there. I think if we haven't all agreed on the same mental model there, then we need to pin that down very clearly.
Yeah.
Yeah. Okay, thanks, Stephen. See, we did have a little time reserved for some additional discussion, additional proposal for rate limit tokens, but Watson doesn't have a thing prepared for that now, so he's going to bring that to the list, or I think he may have already, so, but he'll refresh it so that we can have that discussion on the list. Do you have anything you want to say, Watson?
Yeah, so there's been an email already, and I'll send another one after the meeting, explaining with more of the content and sort of explaining the main differences.
Thank you. All right. Next, I think we have Scott up with talking about some of the various metadata extensions. Do you want to ask
Cool.
for slides, or do you want me to?
Yes, I'll just ask for the slides that I submitted there.
You should have control.
Cool. All right. Short slide deck today. We're really just reviewing the couple drafts that have been adopted at this point, as well as suggesting some future areas of work and where we can kind of dig into next on this extension space. Bit of intro, I'm Scott Hendrickson. I work at Google. A bunch of folks have helped with this PRIVACYPASS extensions work I'm just presenting. So Chris Wood, Gauss Amjad, Kevin Yo, Stephen Valdez, and a few others. So thanks everybody for your work. We'll hop right into it here. So far we have 2 drafts that have been adopted into PRIVACYPASS. We have into the PRIVACYPASS working group. We have the auth scheme extensions draft, which really adds a spot for us to be able to pass some extensions in PRIVACYPASS. And we also have the PRIVACYPASS public metadata draft, which is a mechanism for passing privately and publicly verifiable metadata within PRIVACYPASS. So with these 2, we now have a mechanism, as we presented in, I believe, IETF 118, maybe 117, to pass around metadata through PRIVACYPASS. I'll talk about a use case in the next slide. Some common feedback that we got when adopting these drafts was metadata opens up the ability to identify more clients if we're not careful, or individual clients if we're not careful about how the metadata fields are controlled and how they're used. I'll give some examples of that in the next slide, as well as how this can be protected against. We also need to add more consideration of this into the privacy discussion sections of the drafts themselves. Also, common review feedback was some reference libraries and code around extension crafting would be useful, as well as test vectors for the particular variants of the crypto that we're using. So we plan to address all of these in the drafts. I would encourage, if people haven't taken a close look at the drafts, please do. I'm sure there's a lot more that we can improve on in them. So I actually wanted to go through an example of how we are using extensions in the Chrome IP protection project. I think this provides a useful ground to talk about the expiration extension specifically. I'm going to run through all of the individual extensions that we plan on using for Chrome IP protection authentication. If you're not familiar with Chrome IP protection, basically what we're doing in this project is we're going to be proxying a subset of requests in the Chrome browser. This session is not the one where we talk about exactly how that works, but we do have an authentication mechanism that ensures that clients have met some reasonable bar of use before using our set of proxies. We have 2 proxies. They're speaking masked. There's a whole other IETF session about this. a proxy A, we call it, which is the first proxy, and a proxy B. You need to provide a PRIVACYPASS token in order to authenticate to either of these. So those essentially are going to do token verification and then inspect the public metadata to make sure it meets some constraints that they expect to see there. This is the set of metadata that you'd see on the tokens that we're providing at these proxies. And I'm going to go through it one by one now. So we have an expiration timestamp that basically says, after the timestamp listed in this expiration on the token is no longer valid. We have a geo hint that allows us to present a reasonably correct IP address for the user. We have a service type, which in this case is always going to be fixed to a single value, Chrome IP blinding. We have something called debug mode, which lets us override some geo constraints if we need to test some things out. It's really a developer specific option, and it will always be fixed to a specific bit for production users. And we have proxy layer, which basically says, hey, this token should only be good for a proxy A or proxy B. Can folks in the room just let me know if I can still be heard? I saw Nick's comment on the chat. We're good. Okay. Nick, apparently it's harder to get bytes to you in New York City. I'm in New York City as well, than it is to get them to Australia. So as we can see in this particular type, or now if we go back, some of the privacy concerns that we have on this particular draft are that, if you add too many bits of entropy in a particular token, maybe we're encoding a geo that is too specific to a particular user, that user is going to lose privacy. Because even though we're applying blind signing to the tokens, when we go to validate the token, if the geo has something very specific, like my home address, and I saw that both at the token issuer and at the token verifier, I won't be so private. But if there are many users, like say maybe there's many users for our deployment in New York City, and I'm just putting New York City in that geo, that may still be private. It's really up to the constraints of the deployment, how many users we expect to see in particular geos we have. As we look at the layout of metadata here, we can see that service type, debug mode, proxy layer are all essentially fixed bits, and the Chrome client can actually check that those bits are set to a particular value in production. So we're really just concerned about geohint and expiration timestamp here. Geohint, as I said before, we do have ways of limiting the metadata available there. In this particular case, we would have a well-known set in North America. We're planning for 800 or less geos. And if you're talking about a very large deployment, like the scale of all Google Chrome clients, that may be acceptable. It really depends on the privacy parameters that the particular deployment is looking for. On expiration timestamp specifically, we also have ways to round the expiration such that we think that there'll be many users in a particular bucket of expiration timings. This allows us to have tokens that are still valid for a shorter period of time than a full key rotation cycle, which may be a week or 2 weeks, while still giving the users a sufficient amount of privacy. So say we'll have precision rounded here to, I don't think we've decided on exact value, but it's like 4 hours or 8 hours or something like that. So you have tokens that are valid for a much shorter period of time than the full key rotation cycle. And in fact, our deployment can change this dynamically down to a pre-configured minimum that the Chrome client would validate for. So this gives us a degree of flexibility without having to change like our full key rotation set. So that's a little bit of an example of what we're doing in the Chrome IP protection project. So I wanted to dig in a bit more into expiration timestamp specifically, because as we can see, we have 2 drafts adopted so far. None of them are actual extensions. So some folks gave us some feedback that it might be useful to also adopt an extensions draft to work on in conjunction with the core draft, like mechanics for adding extensions. I agree. And I think expiration timestamp is a great example of this. One of the cool things about expiration timestamp is it allows you to decouple the configuration for how long a particular token is valid for from your actual key rotation cycle. We saw this as a key reliability constraint. If you are not in a nonce style deployment, so in our particular case, we are not, actually in multiple cases that we've deployed, we are not using nonces. So this allows clients to cache their tokens for a period of time. There's no initial challenge. In this particular case, it's very useful to be able to set some shorter expiry window on the token. That's not the full key rotation cycle, especially if you can't necessarily trust that your client code behaves a certain way. So in our case, that we kind of saw this as an opportunity to deploy an expiration timestamp where we can actually adjust dynamically, saying this token will be good for maybe 4 hours, but the next token we issue, maybe it's only good for 2 because the constraints of the field have changed, all within one key rotation cycle. Very interested to hear what you have to say, Watson, on nonces. So there is a draft spec available for this. It's linked in these slides, and we can send it out on the mailing list as well. And I would appreciate if folks could take a look at the expiration draft that we have there. So simple set of next steps, and I'd like to open up for some questions here as well. I think we should continue iterating on the 2 drafts that we have available. I would like to consider also adopting the expiration extension, which gives us nice base to work with, along with more custom extensions like I presented that probably would never be adopted, and that's the intent of the spec there. And then I think we should also go over to the CFRG and request an adoption of the request another adoption call for the partially blind RSA now that it's being used in our draft here. Thoughts, questions?
Stephen?
Stephen Willis, Google. I agree that we need one of the a particular extension draft to be able to think about how the other drafts work, and I think expiration makes sense here. I am worried that we now have expiration in this metadata, we have the expiration of the keys for the tokens, we have the lifetime of the cache, and these are a lot of intersecting things that I'm wondering if there's somewhere we should be thinking about this and discussing it inside PrivacyPass, because leaving it to each of the drafts and having to align all that seems a little bit complicated. I don't know where the best place to actually have that discussion though is.
Tommy?
Tommy Polly Apple. So I have one thing that I was going to get up here before, but first in the chat, there was a comment about nonces. I wanted to clarify, because I think you made a comment at one point that you're not using nonces. My interpretation of that is that you're not using redemption contexts as part of a challenge, but every token still has a nonce in it, correct? You're just
That's
not
correct.
making it, okay.
Yeah, it's not bound to it. Yeah, sorry, I'm using the way my brain thinks about it instead of the way that we should talk about it with the spec.
Okay, cool. All right. So for this, I think we should adopt some extension. I guess the expiration sounds as good as any to do that with, and it's pretty concrete, so sure. I'll need to think more about the details on that. I did have a question overall for the use of extensions here, and how applicable are they to kind of ad hoc scenarios like what you're talking about with the IP privacy solution that you guys are doing, or like what we have for Private Relay, when essentially the client and the server infrastructure all know what they're doing together, and so in that case, yeah, it's very easy to say, I expect all of these extensions, I know I support all of these extensions, and it's all going to be one big happy family, versus a case where a client can come along, get a token challenge, or see tokens with extensions that they don't know about.
Yeah.
Just what is the right way to think about the applicability of extensions to scenarios where, how much do I need to know? Does the client need to understand the semantics of expiration in order to use it? Because if I don't understand the semantics, they're potentially very scary.
Yeah, and I think this gets into the just the technical details of, does a client have the support for handling that particular extension? It obviously needs to. There's an issue open on one of our GitHub repos around the ability to challenge for a particular extension type or a set of extensions, saying like, I would like you to provide a token with this set of extensions. That might give a nice opportunity to help clients handle those, but certainly they're going to need the requisite code in order to fulfill the set of extensions being requested. I'm not sure if that entirely answers your question, but is that helpful? Is that a helpful way to think of it, of the problem,
Yeah.
Tommy?
Yeah, I think that does help. Yes, right. The client does need to understand it. It makes me think, and I know there's discussion later about like applicability on the web and stuff, that also in order to make sure that we are not segmenting user populations based on what extensions they support and know about, that we to some degree want profiles of, you know, like there could be a web profile of saying like, here's a set of extensions that's appropriate, and you want all users to use it together. Because again, like in the case of bespoke proxying situation, like what Private Relay, what your thing does, we can just say all the clients in this population all do the same thing, and therefore it has nice properties.
And it gives us that ability to say, for production clients, this bit is always one. Things like that, right? That are just like simple safety encodings.
So I'd like to see, what are the ways we can replicate that model going forward?
Yeah, that's good feedback.
Okay, Ben?
So it looks like a lot of these extensions you've mentioned are basically proprietary. They're very tightly coupled to some internal details of your of Google's system here. I wonder how you feel that meshes with the IANA registry setup that we have right now for extensions. And should we consider some other kind of namespacing or registration system to acknowledge this idea that actually a lot of the uses for extensions are basically highly proprietary and maybe shouldn't all be mixed into one big namespace with uniform registration requirements?
We actually have a bit of text in one of the drafts that that hits on precisely this, where we basically just say you can squat on a particular extension ID, but you may have to move your system if something standardizes on it. That was our way of handling this overlap. I do think it's a good point, though. Like, if the vast majority of extensions are going to be, or we expect them to be private, or use case specific, like maybe we should have a better system for handling this. But I also think the standardization process takes time, and thus it's pretty easy to dodge around this type of like ID overlap. So we weren't super concerned about it. Even in our case, for example, we just picked a big number and moved on with it.
Okay, Nick?
Nick Doty, CDT. Maybe this proprietary question is getting at the concerns I've previously expressed on the privacy implications here. I haven't been clear on how the client chooses what expiration, what expiration it wants, or what expiration it's going to get, or what it needs in order to use for the service. That the draft doesn't define any of that. Is it just, well, of course it's proprietary, and so like there is no way that you can do it without pre-configuration between the client developer and the service developer, or is the implication that like, no, this is going to be expiration in general if you want to use a PRIVACYPASS token with any service?
Yeah,
because it seems like the privacy properties are going to depend dramatically, like completely, on the details of how that non-standardized piece is worked out. So
yeah, I think this is
I'm
hitting
trying
on
to figure out how we need to protect the privacy here or not.
Yeah, thanks, Nick. I think this is hitting on Tommy's point as well, which is in the case of a non-proprietary deployment where the client, the a tester, or sorry, the issuer and the verifier have all agreed that like these are the parameters we're going to set. It must be rounded. The expiration time stamp must be rounded to this number on like this UTC alignment. For any public deployment, that would also have to be agreed upon. And so we may just pick some big value and say like, oh, it has to be rounded to a day or multiple days with this alignment value. And that would have to be part of the negotiation process that would be occurring that Tommy was alluding to. So I think we have to do more work there to make sure that this this set of extensions works not only for the proprietary use cases, but also the public ones.
But you do intend it to work for the public ones eventually.
That is the intention here. I think we should find a way to make this work for all users of PrivacyPass. Like this particular extension, in my opinion, is very useful for deployments across the board if we can find a way to make it work.
Okay, thank you. That does help me understand better.
Okay, Stephen.
So to Ben's point about like, there's a lot of private extensions here and that's going to pollute the namespace. I think like having a private use space, I think would be pretty valuable. Like, you know that you're only going to use these sorts of tokens in this sort of like use case, and like you're not going to mix it with other things. I think the approach of like choosing some and then hope it doesn't intersect with other standardized things that happened like 10 years from the TLS flashbacks of having random trash show up when we were doing 1.3, I think that's not really manageable. So maybe this is like private use numbers. I think other things have done it that way.
Yeah, I think we had it set up like that originally. We had a block that was all private use, and then we changed it based on some review feedback. So I have to go consult the review feedback to see why we changed it, and then we can see if we can change it back.
Okay, thanks, Scott.
Cool. Thanks all.
All right, I think Watson, you're up now. Do you want to propose, work the slides, or should I?
I think it might work easier if you share them to me Echo, or I can try from my end if that would be preferable.
I have it. Just tell me when you need to advance.
All right, thank you very much. All right, so I'm introducing Draft LAD PrivacyPass BBS 01. There are some other authors whose names did not make it onto the data tracker copy. So PrivacyPass started off encoding a single bit about the user. And there was some close coordination between the issuer and verifier about what this meant. Public made it that it changes that. We've just spent a lot of discussion seeing some of the problems. There's some inescapable trade-offs. If you encode too much, there's a privacy impact. If there's too few, then the origins that are verifying this and relying on the information included aren't getting the data they need. And this might be a manageable thing if the client, when it's getting the token, knows exactly where it's going to spend it and knows exactly what it's going to need. But as we just saw in the Q&A from the last presentation, in an open system, even then it's hard to manage. And when you have origins wanting different data, there's an inescapable tension between putting everything in and putting the minimum in. One solution. So the issuer can give an anonymous credential. We've picked the BBS04 Lincoln Central 04 scheme, and we put the user agent in charge. It has this credential. It can decide what fields to reveal or not reveal depending on what the origin needs. The issuer can cover the whole attribute space without an impact to privacy. And the user agents are the ones that can determine what the privacy impact will be and say, okay, we're not going to show that field's too sensitive, etc. There are some challenges. So PrivacyPass, you usually have one token usable once only. Somehow we need to achieve that here. It's a little tricky. There's some ideas. There's a BBS per verifier linkability idea down there. Origins somehow need to be able to advertise what public data they want. And Yeah, so those are some of the, that's really the big two challenges for folding it in. There are some alternatives. You could pick other schemes. We can talk about what the merits of those schemes were. You can't really use the credentials that people see are using and stuff with SDWT because of the blind signing. That makes it really hard. You can't just throw in a blind signature and say, okay, I'm going to have a hash. I'm going to reveal things because the hash is a linkable thing. Question, and then there's some questions we're working with. Is this a problem that needs solving? And if it is this the way to solve it? And then, I leave it to the chairs and the working group to figure out if we should pursue this as a thing to put out. Floor is open.
All right, I'll bite. Martin Thompson. Watson, one of the biggest concerns I have with a lot of these things is just that first bit. You're not able to hide that first bit, are you? The fact that you have a token, or the fact that you have something that's been signed.
Right. Yes, you can't hide the first bit.
Yeah, I'm concerned about the first bit. The fact that you've hidden all the other stuff and behind whatever, all configuration and whatnot, that's great. I really like the BBS signature stuff. I think they have a great deal of applicability. I think that in some contexts, this will be a distinct improvement. But there's a narrow gap between contexts that can't tolerate the one bit, potentially, we'll talk about that later, and contexts where the additional bits, plural, do not represent a significant challenge for that particular deployment. So you think about the stuff that Scott was talking about earlier. I think I'd be totally fine with all that stuff being just in there. Now, it might be the case that the partially blind RSA stuff is just not as good as BBS. That's like a real good argument, perhaps. But I'm not sure about the privacy story there. Yeah.
Tommy Polly Apple. Yeah, I agree with what Martin says. Like, I like this. I mean, I am not a cryptographer, so I want other people who are more familiar with BBS to talk about the application here. It seems to be cool. It seems to have nice properties. I think potentially from a motivation standpoint, just adding it to the zoo of things and specifying how to use it correctly in this context is nice. And there can be reasons to prefer using this when you are creating new bespoke deployments or upgrading them, that they may prefer to use this. And I think that is one way in which I see the kind of registry and the zoo of different token types evolving, is just to say, hey, we have better, more efficient ways or more interesting ways to achieve these same things. Separately from the question of like, when is this safe to disclose bits? So I think we should pursue it. I think you should continue to do this, and I think we should work on this document here. But then there's, maybe making it boring in terms of like, here's how you use this crypto here, and then we have the broader conversations about when you should use what types separately from this.
Any other comments or questions for Watson? All right, so it seems like there's some interest in this, but it's not quite clear how much at this point. But sounds like something we can continue to discuss to see where. I think we're still kind of unsure as to where exactly you would get the most benefit. Nick?
Yeah, Nick Doty, sorry, I'm still trying to understand the the particular proposal and the implications. Is the idea that like this would to the work going on in you know SPICE or verifiable credentials or something, this would give the property of unlinkability between even if the issuer and the verifier collude. Is that what we're trying to, and then select disclosure on the attributes?
So leaving the whole SPICE mess out of it, PrivacyPass already has unlinkability. It's why it does the blind RSA thing versus just sign a message. What we're trying to achieve is selective disclosure. We're trying to avoid the issue where you need to have everybody in the deployment agree exactly what the public metadata that's presented will consist of and it's exactly what's issued. Because that's a big constraint once you have multiple parties with different needs.
Right. I think I was just trying to compare against from the other side, right? There are selective disclosure proposals out there that don't have the unlinkability, and you're trying to say, well, we could take the unlinkability from PrivacyPass and add the selective disclosure property.
Yeah, I think that would be a way to think about it, but this is really aimed at sort of the place PrivacyPass fits into the rest of the things versus the way that SPICE tries to fit in.
Well, is there some reason, and I'm sure you all know this better than I do, but is there some reason that this wouldn't be applicable to all the credential type applications?
Come watch next IETF and I'll flog something similar in SPICE.
Okay, well, I'm definitely supportive of that. Thank you.
Hi, Ben Schwartz. I just want to, so it sounds like there's a wide range of interesting ideas here. I just want to point out that the group's charter has a lot of language in it around tokens and metadata. And so if what you're doing is small amounts of metadata on tokens, then that looks like pretty much what's in the charter. But if what you're doing is verifiable credentials with unlinkability, then that might not be in the charter. We might have to think harder about that.
Then, I mean, the thing is, once you start adding public metadata, the token unlinkable credential thing, it's semantic. But yeah, we can put the caps in to keep it as small as possible.
So yes, there's no like hard line between these things necessarily. But for example, if your solution fundamentally has like one of the verifiable credentials systems as a building block and is like glued onto that, then you know that definitely changes the question of where the work should be done.
Nick, are you still in the queue? I think you're. How about Scott? Yeah.
Cool. Yeah, so I am not a BBS expert. I would like to learn more, but it does sound like this could fit quite well with the extension negotiation problem that we were chatting about earlier. And I just intuitively wonder if there's a nice fit there. So if we feel that extension negotiation for the public protocols is something we want to solve, I'm wondering if the selective disclosure bit of BBS is a really elegant way of solving those. So I think we should stay more engaged, and that might fit as a natural use case for the BBS proposal if this is in fact something that is useful for that space, because obviously with the way that we've defined public metadata using blind signatures, that negotiation part would be more complicated. You would have to kind of do another round of issuance or do all the negotiation up front and then do your issuance. So definitely interesting stuff here. And I think maybe if we can combine the use case with the tool here, we could have something quite productive.
Yeah, I think so. I think it does address that issue of negotiation.
Okay, great. So I think we should have some more discussion on this. It sounds like there is some potential uses for this. Next up, we have Stephen for our discussion on PrivacyPass and the web.
So this will be a brief overview of PrivacyPass APIs on the web. This is the first part of a discussion that Martin will follow up on, so we'll save like actual discussion for after the two presentations. So as a quick overview, there are really two and a half major use cases of PrivacyPass or privacy style APIs, and I'll get to why it's style. The first is private access tokens, which I think is one of the more well-known ones. It relies on a split issuer-attester model and is one of the reasons we have the rate-limited token spec. This is currently deployed. The other one is private state tokens, which isn't quite PrivacyPass. It doesn't do any of the authentication stuff that we have in the auth docs, though is mostly based on the VOPRF draft. There are a few bits where it's using the batch spec in a way that the batch spec isn't currently defined, but I think hopefully we'll resolve those differences. And then I think would want to move to something like the consistency mirror thing for distributing keys. I think we probably won't ever pick up the authentication scheme part of things, but maybe if there's issuers that want to use that, that might be a thing to look at in the future. It also did have private metadata, but we ended up removing that in the version that's currently shipping. And then the third version is the thing that Scott talked about, which is the IP protection, where you use these blind RSA tokens and the metadata drafts in order to have some amount of data in those tokens. So in all these systems, the attester issuer ecosystem really cuts down into two different problem spaces. One of them is you have a single or fixed set of attesters, parties that the client and you pretty well understand. They have like fixed meanings. You know you can probably trust them, and the client can have some guarantees about what's going on with them. The other one is this arbitrary attester ecosystem, which is what private state tokens uses, where you have a lot of attesters / issuers. And for private state tokens, since it's a joint, they're basically the same thing. So you can't really rely on the fact that you have a small, well-known ecosystem, and you have to do things like limiting how many issuers are used in particular contexts. For PST, this is based on like how many issuers a top-level site is allowed to use. But a lot of this, like the fuzzier meaning of tokens and the fact that you really only have these mitigations at issuance and redemption time, I think add complexity to what we can actually say about the privacy there. So some challenges are, we have all these members in the ecosystem that are interacting on different websites. How do we reason about that? How do we limit that? We can have these sort of hard limits if you're only allowed to use a fixed number of attesters, but then you run into things where you've chosen your attesters and now you're stuck with them. In other parts of the IETF, we've seen that these sorts of foot guns are really terrible problems, and it would be nice not to have them. Another thing we have is because we have a bunch of attesters in the ecosystem, we can't do things like private access tokens does and the redemption context thing, where you always just like do your issuance right when you're doing a redemption and use that as a sort of freshness guarantee and binding to that context. We run more into the problem of if you issue right when you're redeeming, you're going to have bigger timing attacks just because you might have a lot of smaller attesters and smaller issuers that like they only see 10 people visit them in an hour. And these sorts of timing attacks get a lot worse here where like your ecosystem is built in this shape. I think in terms of the meanings of tokens and like the value that you have within tokens, I think Martin's discussing more about that in the next presentation. But yeah, there's a bunch of open questions and future work that we've sort of like made arbitrary decisions on these API slides. Some of them maybe we can solve more broadly within PrivacyPass, and some of them we just might have to leave to the applications. A lot of it is how lots of insurers interact within an ecosystem. There's also how ecosystems interact. Like if you have multiple things that use PrivacyPass in like different layers, there is some amount of like privacy issues there that probably we should think about. There's how we technically classify tokens, which will be the rest of this discussion. And I think the meaning of tokens changing over time, like even if it's a well-known meaning, I think that adds extra entropy sort of to the token, because like even if it's the same key, like you could have a bunch of keys on one day and a different set of meanings for those same keys on a different day. And it's sort of mentioned in the current drafts, but not to like a very deep degree. And though it's not clear, like maybe this is some architecture draft that we want to add or something else. But yeah, that's for the overview. And Martin.
Do you want me to?
No one ever has two devices. No one ever. Oh, look at that, blank screen. All right, well done. Try that again. You can start it up. It'll take me a little while.
I don't see anything yet.
No,
Try it again.
Oh yeah, we use cookies. Ask slides.
There we go. Okay, you should be in business.
Oh, it's such a tiny little window. All right. All right, I'll try to make this quick so we can have some time for discussion. There's a lot of material here. I'm going to skip over some of it as we go in the interest of talking more, or you talking more, me talking less. So I spent a bit of time looking at this one. There's a write-up that I can provide a link to. My interest is in how PrivacyPass is built into web browsers. Stephen already talked about the two major deployments. We're not talking about Cloudflare's PrivacyPass browser extension. For various reasons, that has none of the problems, by and large, that I'm talking about here, because there's an explicit decision at the point that someone installs that extension to more or less trust Cloudflare to operate it. And as we'll see, that's kind of important. So yeah, there we go. So just to sort of put this into perspective a little bit, we have two basic authorization modes that we talk about here. And PrivacyPass is kind of novel in this respect, because you only get a sort of loose coupling between the thing that you use to authorize and a person. It's really a group of people have the same or indistinguishably same tokens, and that forms an anonymity set. And the idea is to make that anonymity set as large as possible so that you can provide the people in that set some degree of privacy. And timing, a bunch of other reasons, it gets complicated, so you make them even bigger again, and then eventually at some point you have something that works reasonably well. And the whole point of all of this is that a lot of the uses of PrivacyPass rely on having very low activation energy. You don't want to get into a situation, for instance, if you're using these for anti-fraud purposes for advertising, you don't want to go asking permission for people to put a token in the browser. You don't want to have a whole bunch of friction involved with a lot of these scenarios. And the VPN case is a really great example of an application where it's low stakes authorization. And so PrivacyPass is entirely appropriate for that. Now, of course, because my phone went to sleep, I have to wait for it to reconnect. Wonderful. Crypto here doesn't eliminate the need for trust. It just reduces and shifts it around a little bit. So we all know this, so we'll skip past that one. Now, the idea is that if the privacy is good, we don't have to ask difficult questions, right? but what we're doing here is we're trading the fidelity of the authorization signal for the availability of it, essentially. Yeah, Nick's nodding here. He's thinking about this one a lot as well. So here's the key problem. The presence or absence of a token carries a bit of information. And the timing of the arrival of that carries some amount more information. And there's some amount of extra information that's available in the context in which a token is presented that also carries information. Now, this information might not be useful, but when you're designing a system that uses PrivacyPass, you need to account for these information leaks. And with loose bindings, you don't necessarily get to narrow things down without sort of pulling on that privacy constraint a little bit. So we talk in the specifications about binding to a particular origin, binding to a particular usage context, and you saw in Scott's thing binding to a narrow window of time, binding to a particular proxy instance, binding to a bunch of other things. Now, of course, the more bindings you put in, the smaller the anonymity set. And so there's a bit of tension there. And this is a deliberate choice we make when we're designing one of these systems as to how much privacy we want to provide. You want to ask a question, Tommy? I think I probably skipped over something or fumbled it.
No, just if you go back a slide, just to noodle on the target origin scoping. Yeah, at least for how we define it in like the normal types, if you're not adding some extension, it's generally like the origin can choose to say like, I want to scope you, but like that bit of information is only ever seen kind of by the origin and the client itself. And from the perspective of that origin, that anonymity set is the same it would have seen otherwise. Not
necessarily.
Okay.
If you think about if you have two origins and they both accept the same tokens, then the anonymity set is the set of people across that access both of those origins. Whereas if you want to bind it to your specific origin, you've prevented the expansion of the anonymity set across origins.
But if in my challenge from my origin,
yep.
I have two options. I can say you need to give me a token that is for my origin only, or one that's for anyone. Yep. But in either case, you just give me one token that I have no way to correlate to anyone else, and I just kind of made a choice. And so, like by making that choice, the origin knows like it'll just get that type back. It doesn't know which one you were in.
Yeah, but the set of people that present the origin-bound tokens to you form an anonymity set.
But it is the same people who would have presented in the other case.
Okay.
It doesn't change the population size.
Maybe I'm wrong about this detail, but
it's a minor
really
detail. Sorry.
Yeah. So we have this system. We have a number of different actors in it. I'm making some presumptions here about the fact that people trust themselves, so maybe you don't care about that. But there's a bunch of decisions we have to make in any deployment about who trusts whom, and that's not bidirectional in each case. There may be some amount of trust flowing in one direction, but not the other, and we have to think about all of that through here. It makes it a little bit complicated, and then we're back to the one-bit thing. Question is, what does a bit mean? So from the perspective of the client, the meaning of that bit is essentially unknowable. This is one of the ways where the additional metadata in the BBS proposal is good, because then the meaning of that information can be known. But the meaning of the bit is essentially unknowable. So if you think about it, and a tester may receive a bunch of information about you when you ask for an attestation, and it may pass some of that information along to the issuer. We sort of trust that they don't, but it's always possible. And that information could be bound up into that bit. Now, most of the time, it is exactly the sort of thing that you might expect to be passed along. It is, this is a trustworthy person, or some analog of the same sort of area. But concretely, they could mean anything. And the design of your system and the trust assumptions that you have determine what that meaning is, maybe. And that's where we come to the problem. There are no guarantees. There's no guarantees about the meaning of the bit or even about the size of the anonymity set because we have built a system where there could be just one person asking for these tokens and everything is set up correctly. Everything could work, but it just so happens that within this particular window of time, there's only one person asks for that token, and that person then becomes identifiable. And there's nothing in the system that would guarantee this, apart from the trust that we have in the entities that are operating. Right. And so that's where we come down to everything. And so trust is key. But the web, yeah, we don't really have a whole lot of trust on the web. Did I skip a slide? Yeah, there's a bunch of options here. But ultimately, there's the slide that I should have had in there, and I realize that right at this moment, is that when we think about deployment to the web, we can't just have trust that Cloudflare is going to operate their service in the way that we believe. Yes, we might trust Cloudflare, but they can't be the only provider of this service. We have to have a means to add other people. Now, how do we establish trust in those other people? And there's a tension between centralization and being able to trust the set of people that are involved in this. And a bunch of different decisions have been made. You will see that in Apple's solution, currently there is only one attester, by my understanding, and a very small number of issuers. And that works because those actors are generally trustworthy. You can make an assessment based on the list that are operating, which I'm not sure is public, but it's not exactly a huge secret. On the other end of things, Google have deployed private state tokens, and any website can issue one of these tokens. And, if trust is everything, we've just given them one or 6 bits of information that they can pass around between websites, which is, I don't know, maybe that's something that you can tolerate. Personally, I don't think that's quite good enough. So discuss. And I'm going to sit back down again because I don't want to be up here as if I am some sort of authority. Sovereign identity providers. Yeah, it's an idea that's been discussed. I realized that I had a call with the folks at Google where we were talking about all the different options and I didn't raise this one. So it turns out that most of us have some form of identification document that a government has given us, whether it be a driver's license or a passport or something similar like that. The existence of one of those things is a scarce resource, and it might be possible to leverage that. And then the signal is something that we understand, which is you have a government issued identity document with some rate limiting controls on that one, which we can go into the sort of cryptographic details. That may be an option for us to explore. It's not PRIVACYPASS at that point, but it might be useful for things like anti-fraud.
Yes, one question about the Apple registration. So that's mostly for issuers. Like, you still only have the one attester. Do like bad acting issuers actually add as much of a problem to the ecosystem, since like they can't choose separate like reasons for why they're issuing tokens, right?
Right. Okay. So, sorry to jump the queue. Just to answer that. So yes, currently the default behavior is we have the one attester, and for like the trust model that works well. And like, as we were saying, like if you want to make sure you have a large anonymity set, like the client essentially needs an advocate And then an attester who you're disclosing information to, and you kind of already have to have a trust relationship with them, is in a good position to do that. We are relying on the attester to make sure that the issuer that you're talking to is being used by many clients all at the same time, and there's not a timing attack, and so the registration exists really just as a way to say, do you have a way to forward the tokens? Is there MTLS there? But then also to have essentially an entity on the books that you can guarantee the size of the anonymity set. You can say, okay, there's this thing I know about. They are claiming they're going to have many clients. We're going to check that many clients are going through them all the time. If you fall below the threshold, then you could target people, so we'll stop allowing it to be used. With regards to the trustworthiness of an issuer, at least in the model that we've done with the split attester issuer, the trust relationship there, the choice you can make is that it is only the origin that's trusting the issuer. So and they presumably have some contractual relationship, or they literally the origin really is just the capture provider, and the issuer is the back end of the capture provider. So if the issuer wants to downgrade its value, then origin should just choose to no longer work with that issuer, and that doesn't diminish the value that other issuers have, even if they go through the same attester. So I think from that perspective, it quote unquote works. I think the problem with that is, how do you ensure that many other attesters can enter the ecosystem, that it is not a situation where you have gatekeepers. That's where Martin's suggestion of if you had the identity provider essentially be your attester, that's a way to do it. I think that's the problem I would like to solve, is how do we get Firefox on Linux having an attester that is reasonable? Because if you do that, then I think it becomes more tractable.
Okay, Scott.
So I think what I'm about to suggest actually requires what Tommy's alluding to as a prerequisite. But I'm wondering if we have a lot of the tools that we need to solve most of this, almost at our disposal. We have key consistency, which is looking at a part of this problem. How do we make sure that a client isn't getting served a unique resource? We have metadata, which starts to define what is a client's particular anonymity set. We now it seems like we need a way to measure the actual anonymity set size, which is the hard part of this problem, right? Because there are many ways when you try to build this where you end up with gatekeeper. There are many other ways when you try to build this where you end up with a very centralized entity. But if we could push towards something where maybe it's an evolution of key consistency or something else, where we can start to measure the anonymity set size, I'm wondering if it does actually a pretty good job of addressing a lot of these problems. And that's also a very good way of handling the more dynamic nature of these public deployments. Whereas in the private deployments, we can handle this. We can handle this by just knowing, exactly what our clients look like and what they do. So I think this is an interesting area for us to explore in the future. It's not an easy space, certainly if with the goals that are just up on this screen right now. But we could find it to be quite a productive route. It will require us to define what are maybe not the exact parameters for an acceptable anonymity set, but it will start to require us to define, what are the bounds of a reasonable anonymity set, which is new work for this group. Thanks.
Okay, Ben.
So I have two ideas that I tend to harp on this topic, and I'm going to repeat now. One of them is the client IP address is highly identifying here, and as a result, any situation where we're really concerned about this privacy, in my view, we also are going to have some kind of transport proxy between the client and the origin. And that transport proxy is inherently another entity with this kind of trust relationship, where I have to believe that it is going to make best effort to preserve my privacy here, and not just tell the destination my IP address somehow. So I think we should consider that, maybe we already have an entity in the system that is trusted in this way, and we should leverage that rather than trying to build that same capability independently. The other thing I want to propose, which is a little bit of an oddball idea, I admit, is instead of assuming that every issuer potentially leaks, we've been calling it a bit of information, that's not quite right, but we've potentially leaks information about the user. One idea that I would like is to be able to have origins essentially attempt to redeem tokens from different issuers and potentially fail until it succeeds, and then no longer be able to make further requests. So as an origin, I can stack rank all of the issuers that I've ever heard of, from the ones that are most useful to me as a signal to least useful, and walk down that list until I get a positive answer from the user, but I can't combinatorially check which subset of these tokens the user possesses, which might create a fingerprint.
Okay, Watson?
So I hesitate to put words in Martin's mouth, but I think a lot of the responses here are sort of missing what I understood to be part of the objection, which is it's not that we don't have a large anonymity set or a small one, it's we don't know the meaning of the bit. It could be as innocent as you're on a browser that is actually operated by a human. It could be a bit that has information where we would consider websites passing it around and making decisions based on it to be really bad. So I think in that context, nothing we have about like the testers can limit the issuance, especially if you have hidden metadata. That poses a real challenge.
Okay, Nick. Oh, you're Steven, sorry.
Yeah. So I guess one difference between like what we're doing in PST and PED and like also runs into a lot of this discussion of like maybe you have like a trusted provider, the operating system, the browser, things like that, is I think like for PST we're trying to enable more generic use cases in a way that is more privacy preserving than like the existing state of the world. I think like if we knew exactly what those use cases are, I think there were a lot more like fine-grained and like directed solutions to this space, even still using PrivacyPass, but having a like more concrete governance structure for those particular use cases. I think it's this generic governance structure for like supporting wider, less fuzzier things that I think would be useful to have like some solution that isn't just like arbitrary decisions by like different parties. To Ben's point about, I think having a list of issuers and walking down them, I think you still reveal a lot of information by the fact that the presence or absence of a token earlier in that list like is a huge amount of entropy of that list is pretty long. So I don't know if that's a particularly great solution, at least in that space.
Okay, now it's Nick.
Hey, just want to add a little bit of context here. Some of these ideas were explored in the PrivacyPass extension back in the day, including like FIDO-based attestation, which was implemented and deployed, I think, in 2020, as well as an OAuth-based replacement for the CAPTCHA for the attestation, which didn't end up working out for privacy reasons, but may have an opportunity to now that the newer mechanisms that are more privacy preserving exist. So there were issues with both of those back then, and I imagine there still will be too. And the governance structure is a really important question.
Okay, T-Bald.
Hi, Thibault from Cloudflare, working on the extension that's actually mentioned. So 2 points, I think, based on like Martin's draft is So like there's been some discussion like on the governance, at least for the issuers. One thing that exists in current deployments is the governance and the issuers that are trusted by clients is like implicit, and like users like don't have a choice where like they're able to configure like new issuers or like be able to like disable them. And I think that's something that could be explored down the line as a way to actually like enforce and like provide like more transparency in the trust and the issuers that are being made, and I have some like informed choices. Another point regarding like the existing deployment models is like regarding attesters. Attesters have like no API defined in the current drafts. And I think at least exploring the possibility of standardizing on what attesters provides, should it be like the issuer they trust or like some sort of like message or bit that they would assess, could be very, very valuable to like ensure we have like a diversity of issuers that would trust these attesters.
Okay, Nick.
Yeah, when these issues have come up in anti-fraud contexts, I've been trying to keep a sort of shorthand list of properties that I think we should consider. My current list is rigidity, granularity, freedom, consolidation, privacy, and efficacy. I think that granularity and rigidity are perhaps most relevant here. I think Martin and others have made the important point that, well, just having it down to be a single bit doesn't tell you what that bit is, but I do think it's still pretty significant. It's much easier to abuse a large number of bits than it is a single bit. And it might be, and maybe this is where we should be getting to, it might be easier to provide accountability, that it might be easier to, after the fact, have people evaluating the system and trying to see if there is abuse, and that if there are many bits, it might be very hard to ever uncover abuse, whereas if you just have a single bit, but you use it in this pathological way, that we could try to uncover it. But I also think rigidity is the other type of protection that for any system, I think we need to have some way to make it work, even if the user doesn't have the token. And if we could actually do that, I think it would still be very useful for many of the use cases that we're talking about, because we're talking about trying to prevent large-scale attacks, but doesn't need to discriminate against individual users. So I do wonder if we could be considering protections against rigidity for things that are low granularity.
Okay, Mark.
Could you go back a slide? Oh, that was you? Okay. Yeah, I'm glad that we left it on this slide. I think this is the right place to focus, and I got to say I'm skeptical of the possibility that we can come up with a governance structure that balances everything correctly here. It seems like a very tall order, especially without having the bad effects on the web. And so it was just interesting to me. I was listening to the other comments, and a couple times consolidation was mentioned by Nick. Earlier, there was mention of centralization, and that reminded me of something that we put into the centralization RFC a little while back, which was when you have the need to have a point of centralization, when a protocol requires that, which sometimes happens, and that's legitimate, you really try and leverage an existing point of centralization rather than add a new one. And that takes me to the last line here. That is an interesting thing to try and leverage, especially when it kind of helps you decide what that bit means. So maybe that's where we should be focusing.
Okay, Tommy.
I'm responding, Tommy Polyapple. I'm responding to Watson's comment earlier, which is very good. But I want to pause it and see if people can poke holes or more in it. That the anonymity set problem actually is or can be related to the meaning of the bit. So like, again, like going back to the model, if you have like this split attester issuer, if I as the client know from the attester, because I trust it in this model, that many other clients are using it, and that's how I determine my anonymity set, then I, as the client, also know that the meaning of the bit that anyone's getting out of this is essentially the common denominator between me and anyone else in that anonymity set going through that particular attester, whoever passed that check. And so, like, the fact that I have an anonymity set means that I have a population that all get something equivalent, and whatever is common between us, whatever was being attested to, becomes the meaning of that bit from that particular client's perspective. And then when you look at the origins who are redeeming those, their view of the bit is based on the set of all of those attesters, then essentially what is the lowest common denominator amongst all of them. So it doesn't quite solve all of it, but I do think we have an entanglement between knowing what our set is and our population is and the meaning of the bit.
Okay, I'm afraid we're out of time. I think this session ends 4:30. So thank you. I think this is a good discussion. I think probably we need to continue to talk about this. So thanks, Martin and Stephen, for leading us through that.
Yeah, there's some really gnarly. There are upstream government